Hello, this is Mr. Kinyanola, and in the last episode, I showed you guys how to prove whether two triangles were similar by side-side-side similarity. In this episode, I'm going to show you a second way to prove that two triangles are similar. And if you remember, two triangles are similar if they're just simply dilations of each other. And if you dilate it, that means that all the sides are proportional. They're all enlarged or shrunk by the exact same scale factor. So what I'm going to do to this triangle is dilate it so that it has a larger me, and the original is a mini me. So here's a larger me, and it's a dilation, so that means that it is similar to the original triangle. So all the sides are enlarged proportionally. But this time, instead of looking at the sides, we're going to look at the angles and see what they tell us. Let's look at the angle A's for a moment. So I'm going to put angle A, this angle A, on top of the original angle A, and look at it. It fits right on top. Perfect overlap, so that says that angle A's, both angle A's, are congruent to each other. Now let's compare the angle B's with each other, and yeah. Look at that. They fit right on top of each other, so they are also congruent. And just for funsies, we really don't have to compare the angle C's, but let's compare the angle C's right there, and let's move it, and the angle C's are also congruent. I said we didn't have to really compare the angle C's because if two angles are already congruent, so for example, let's say angle A is 70 degrees, and that means that this angle A has to be 70 degrees because we just showed that they overlap each other. And if this angle, and these are just random numbers I'm putting here, if this angle is 30 degrees and we know that the other angle B is 30 degrees because we just checked it, then angle C's have to be congruent to each other without even looking at it, just by doing triangle sum theorem, because 30 plus 70 is 100. 180 minus 100 would be 80 degrees. So, yeah, there you go. So instead of looking at the sides, all we really have to do is look at two pairs of angles and see if two pairs of angles are congruent. And that is called angle similarity, or AA similarity for short. So put this in your notes. Let's enlarge this so it looks nicer. So this says that if two pairs of corresponding angles are congruent, then the two triangles are similar. So that's it. So this time we don't have to, again, we're looking at the angles, not the sides, and if two pairs of angles are congruent, we can assume that the third angles are congruent, so we can conclude that the two triangles are similar. So I'll show you guys some examples of how to use angle similarity in a flowchart. All right, so here is our first example of using angle similarity. If you notice, they don't even give us any information about sides. There aren't any measures. There aren't any tick marks. So yeah, we're kind of forced to use angle similarity because they only give us information about angles. So let's look at what we got. We have angle J is congruent to angle G because both are 87 degrees. So we can say that our first bubble, and I know it's in side similarity, we put their measures, but here we're just going to say angle J is congruent to angle G. And why are they congruent? Because it says that they're congruent. Both are 87 degrees, so that is given. Next one is, well, 68 isn't congruent to 25, so we can't just give up. Let's not give up. We're not quitters. Come on. So let's try to figure out what angle I is. Let's use triangle sum theorem. So let's get our calculators if you don't want to use mental math. Now let's figure out 87 plus 68 is 155. And triangle sum theorem, all three angles add up to 180. So 180 minus 155 is 25. So angle I is 25 degrees, and look at that. Look what we have here. Two angles that are congruent to each other. So we can say that angle I is congruent to angle F. Okay, and that's not given because we didn't know that one, but we had to figure that one out. And the reason for that is triangle sum theorem. If you don't want to spell theorem, and some of you guys can't even spell theorem, just put THM, thum. And if you remember, it's just angle similarity. We don't need to figure out the third angles, because if two pairs of angles are congruent, then we automatically know that the third angles are congruent. Look, 25, 87, we know that's 68, so this has to be 68, but we don't need to state that because if two are already congruent in the third one. So we already have enough information. So now we can say that triangle, now let's go from the small triangle to the big triangle and make sure you put it in order. So here's how I like to make sure I'm going in order. Let's go from smallest angle to the largest angle. So I, H, J. So 25, 68, 87. So I'm going to say triangle I, H, J is similar. And then now we're going to go to the big triangle. We'll go from the smallest angle, F. So triangle F. And we know that this is the middle one because we know it's 68 because that one's 68. So E and G, the largest angle. So that's how we know it's in order. The corresponding angles are congruent. The 25s, the I, F, H and E, both are 68, and the G and J's are both 87, so G and J's are the third letters that we put in there. All right, so look at that. And now we put our arrows. Because these two pairs of angles are congruent, then we can say that the two triangles are similar. And don't forget your reason. Angle, similarity. Look at that. That's it. Only 3 bubbles needed. But don't forget your reasons. Don't forget to put similarity here. Don't forget to put congruent there. So there's a lot of little details that you have to remember so that you get this flow chart correct. Okay, there's that. All right, next example. Use a flow chart to prove that the two triangles are similar. Again, can we use side-side similarity? They don't give us any information. There aren't any tick marks. There aren't any measures. So what's our next option? Let's see if we can use angle similarity. So prove that triangle QRS is similar to triangle QKL. So let's see. Let's always start off with what they give us. We see that this has 2 arcs. This has 2 arcs. So they gave us this. Angle K is congruent to angle R. Why, you say? Why, you say? Because they already gave it to us, so it's given. That's the why. All right, now we need another angle, another pair of angles. We can't say that these are congruent because there aren't any arcs there. But what's up with this angle and this angle? What's up with these two? Look, they make an X. What do X's make or have? Vertical angles. So we can say, now take a different colored pen. Don't use black or red. Get a different one because this one we figure out on our own. They didn't give it to us. So put 1 arc here and 1 arc here. Okay, so this angle is congruent to this angle. And you may be tempted to put angle Q is congruent to angle Q. Do not put that, because if you put angle Q, which angle Q are you talking about? You say, oh, I'm talking about this one. I'm talking about this one. Okay, you have to be specific in your name. So if I took my highlighter and I highlighted what made this angle right here, it'd be this one. So these 3 points. So if we connected the dots, it'd be angle LQK or KQL. Okay, so angle LQK is congruent to, now don't put angle Q there. Let's connect the dots. If we were to make that angle go from here to here to here, so the name of this angle right here would be RQS. Angle RQS. Or if you want to go the other way, SQR. Okay, so be specific. Don't just put angle Q, because angle Q could be this angle right here, this angle right here, this angle, all these different angle Qs everywhere. So be specific. LQK is congruent to angle RQS. And why? What kind of angles are these that we found in an X that are on opposite ends? Yeah, vertical. We know vertical angles are congruent. So the reason? Vertical angles. So we have one pair of angles, we have another pair of angles, so we can come to our conclusion that triangle, and look at this, they already wrote it for us. So QRS is similar to triangle QKL. Let's say that. And the reason why we came to this conclusion is because of angle K being congruent to angle R because of that given, and angle LQK is congruent to angle RQS because they're vertical angles. And the reason that we can come to this conclusion, why? Because two angles are congruent. So angle, similarity. There you go. So don't forget, put similar, congruent, reasons there, arrows. If you miss any of that, then it's wrong. You did all this information, but if you just miss this little similarity symbol, this one, or an arrow, so it flows. You got to show the flow. Angle flows into the conclusion, and there. All right. Next one. Whoa, this one is a little tricky. Use a flow chart to prove that the two triangles are similar. They don't give us any arcs. They don't give us any side lengths. But they do give us these little arrows here. And if you guys remember, what do arrows mean? So this one's a next level flow chart. So pay attention, pay close attention. These two arrows, if you guys remember what arrows mean, that means that they're parallel. So we can say that RS, so line RS is parallel. And let's put a little symbol saying that line segment RS is parallel to FE. Okay. And why are they parallel? Because they put the arrows, they gave it to us. So the reason, given. Okay. But that doesn't tell us any angles. Remember, we need two pairs of angles. We just have something about some sides never intersecting. So, but we're going to use this. This is a hint. Use this as a hint. When lines are parallel, okay, so I'm going to highlight this to make it a little more visible. Here are two lines that are parallel, and parallel lines have this right here called a transversal, okay? And when parallel lines are parallel, then we have angles that are congruent. So we can say that because these lines are parallel, okay, and if you need to rewind this, please don't just write this stuff down. Make sure you really understand this part, because this part is a little tricky. So we got these parallel lines and a transversal, and when lines are parallel, we can say that this angle is congruent to this angle right there. Why? What's their position when these parallel lines? Well, they're both below the transversal, they're both to the left, so they're corresponding. And if you remember, when lines are parallel, corresponding angles are congruent. So we can say that angle, now you have to be specific. This angle right here is formed by GRS. If we connected the dots, right? G to R to S would make this angle. So angle GRS is congruent to angle, okay, connect the dots, RFE. So GRS makes this angle, and RFE makes this angle. And why are they congruent? Because the lines are parallel, and when the lines are parallel, then corresponding angles are congruent. Okay, so yeah, look, these parallel lines did help us. These parallel lines gave us one of the angles, one of the pairs of angles that had to be congruent. Now we have to figure out another pair of angles that are congruent. Well, look at this triangle. GFE, no, GRS, GRS. Look at this small triangle. Focus on this little small triangle right here, GRS. And now focus on the bigger triangle, GFE. Do they have something in common? Do they? Do they? GRS, GFE, GRS, GFE, G. They both have angle G. So triangle GFE has angle G. Triangle GRS has angle G. So angle G for the small triangle is congruent to angle G for the big triangle. Both triangles have angle G. So we can say that. Okay, and we don't have to be specific. We can just say angle G because there's only one angle G out there. So angle G is congruent to angle G. It's congruent to itself, like you're congruent to yourself. Okay, this blue pen is congruent to this blue pen itself. And both triangles both have angle G in it, so we can say that they're congruent. And the reason, this new one, this is a new reason. It's called reflexive. Okay, like a reflection. Your reflection is congruent to you. So these are reflections of each other. They're congruent because, hey, it's itself. It's congruent to itself. It's congruent to its reflection. So, hey, do we have two pairs of angles that are congruent? Yeah, here are the two pairs. Now we can come to the conclusion that triangle GFE is similar to triangle GRS. Because we have one pair of angles, we have the other pair of angles. So angle, similarity. That's it. Look at that. So when you have parallel lines, look for some corresponding angles, or look for some alternate interior angles, or alternate exterior angles. Look for some angles that are congruent because the lines are parallel. And then also check, do the two triangles share an angle, have a common angle? And you could use that. So there you go. Another option, if you really wanted to figure this out, you could even said that this angle right here is congruent to this angle right here because they're also corresponding angles with these parallel lines. But we only need two pairs of angles. All right. So if I went a little fast on that, rewind it and play it a little slower, or get ready with your questions. With me, or if you're not in my class, with your teacher. All right, last one. Use a flow chart to prove that the two triangles are similar. Okay, so are these really similar? They actually give us numbers here, and yeah, we have some vertical angles, but I'm really curious to figure out what this vertical angle measure is. So I'm going to use triangle sum theorem. 70 plus 54 is 124. These two add up to 124. I'm going to subtract it from 180 degrees. So this angle would be 56. Its vertical angle would be 56. And I want to figure out what angle S is, just cause. And you'll see the cause reason soon. So 68. 68 plus 56. Triangle sum theorem. I'm going to subtract 124 from 180, which is 56. Is that right? 56 plus 56 plus 68. So, I mean, look at it. Remember, they don't give us any sides, so we're forced to try to use angle similarity. We need two pairs of angles that are similar, or that are congruent. But really, we only have one pair of angles that are congruent. This 56 with this 56. This 56 isn't congruent with any of these angles. This 68 isn't congruent with any of these angles. So, because we only have one A and we can't come to a conclusion with a similarity, hey, not similar. Okay? Not similar. And if you want to put the reason, triangle sum theorem. When we use triangle sum theorem, we couldn't find two pairs of angles that were congruent. So yeah, these triangles are not dilations of each other. They may look like triangles, but they're not proportionally similar. All right, so that's it. That's how you use a similarity.